Okay, yesterday we worked with recursive series. Just a different look in regards to a series rather than a sequence. A sequence. You had some problems that dealt with finding nth terms, basically working through the sequences again. You're looking at basically the same general formulas that we had before. When you're dealing with an arithmetic sequence, we can find Tn, some term number n is equal to T1 plus D times n minus 1. This is your explicit formula that you had to deal with. We now have the recursive formula where we have Tn is equal to Tn minus 1 plus that common difference D. You have to remember, though, to put T1 is equal to, you need to know a starting spot for your T1. When you talk about geometric, your Tn, your nth term, you can calculate by T1 times r to the n minus 1 power. And when you're talking, this is your explicit formulas. When you talk about recursive, you have Tn is equal to Tn minus 1 times r ratio. Whatever you're multiplying your ratio by or your term by, your previous term by to get to the next term. Questions you had? They had solutions provided for you. Questions? Once again, a lot of just manipulating these two equations at this point. I know we're near the end, I get it, but you need to put a little effort through it. Plus, it'd be really boring if we weren't doing anything. At least it wouldn't be for me. Then we're going to talk about series. And this will be the last of the new material for the next quiz. Once again, we'll have two quizzes that we'll be dealing with here. And I'm trying to help your grades out a little bit in regards to having a couple more grades in here. Going back to sequence, we have a finite sequence. It has a definite number of terms. And we have what is called an infinite sequence, which has an infinite number of terms. So we have two different types of sequences we can be dealing with. We can be dealing with a finite sequence, which has a definite number of terms, and you can count up your terms. It stops. You have nothing at the end. 1, 4, 7, 10, 13, 16. It stops. Or you can have an infinite sequence, which is an indefinite or infinite number of terms, and how that is signified is you'll get a comma and a dot afterwards. It will continue onwards. So we have two different types of sequences we could be dealing with. We have finite, we have definite or infinite. Right now we have finite sequences we've been dealing with. We have a starting spot, we have an ending spot. When we talk about a series, though, a series, we take our sequence, maybe. We take our sequence and we add all the terms together. It's the sum of the terms of a sequence. That's your thing. the sum of the terms of a sequence. We signify this by Sn, with a subscript n. You have the big S there, capital S, that gives me the sum of the terms. So basically what you're doing here is you're taking the commas out and you're adding an addition sign. You're taking the commas out and adding in the addition sign. Now, if you're sitting on a math entrance exam, or you're on a math test somewhere, and they ask you to find the series, and it's a small number of terms, I would do exactly what Justin's doing over here. He slid out the calculator, and he's going to add 3 plus 7 plus 11 plus 15 plus 19 plus 23 plus 27 plus 31. Add them up. It does not take long. It takes you a matter of 20 seconds to add all those terms together. Go ahead. What do you get? Justin, what do you get?
136.
136. The problem we run into is, what if I ask you to do the first 500 terms? Or the first 1,000 terms? I would not suggest now typing in 1,000 terms and adding them up. Okay, I would not suggest that. So let's look at another method of madness to be able to deal with this. The nice thing we have with addition, that we have all addition here, we have all kinds of properties that we can deal with. The commutative, associative properties we could deal with. Basically, it does not matter which order we add these things into. We can add 3 plus 7 plus 11 plus 15 and so on. Just add it down the line. Or we can add 3 plus 31 and 7 plus 27 and 11 plus 23. We can add these in any order we want. It doesn't matter. So let's do some trickery here and let's see what happens. If I would take 3 plus 31, we get a value of 34. If we would add 7 plus 27, we would get this 34. If we would add 11 plus 23, we would get 34. If we would add 15 plus 19, we would get 34. So we could add 34 plus 34 plus 34 plus 34 if we wanted to. And we'd still get our same 136. Or we can use some multiplication, because multiplication is a shortening of addition. I have 4 times 34, and I still get my 136. Well, let's take a look at another one down here. I'm going to add another term to that. And if we follow the same method of madness, and we add the outside, 3 plus 35, we get 38. And 7 plus 31, we get our 38 again. are 11 and 27. We get 38. Are 15 and 19. We get 38. Same thing. But the problem we run into is this number 19. So we would have to add 34 or 38 plus 38 plus 38 plus 38, but then we'd have to add in this 19. Well, the question is, that really doesn't help us out too much. That doesn't shorten our mathematics very much. And that's a lot of dominoes to fall to get to the point of adding this up. Why not just add up all the terms? You're exactly correct. But once again, when we get to 500 terms or 1,000 terms, that becomes a little bit more difficult. So how else can we deal with this? Well, if we take a look, we have 4 38s, and then we have a 19. What could we do to 38 mathematically to get back to 19? Two things we could do. Divide by 2 or subtract 19 from it. Okay, we can divide by 2 or subtract 19. Well, let's take a look at the division by 2. What we have here is we have 3 plus 31. I'm sorry. 3 plus 35. And if we would divide that by 2, we get a value of 19. Well, when we add two numbers together and divide by 2, what are we finding of those two numbers? Add two numbers together, divide by 2. What are we finding? The average of those two numbers. Well, let's take a look at what an average is. What's the definition of what does it mean to calculate an average? Well, when we do your grades at the end of every 9 weeks, we calculate an average. We take all your test scores, add them all together, and divide by the total number of test scores. And what we get is we get a representation number that represents an entire set of data. If my 4 test scores were 70, 80, 90, and 100, that's my 4 test scores. And if I wanted to find an average of those 4 test scores, what would be the average of those 4 test scores? Grant, what do you get? 85. How'd you get that? Okay, we added these together, and then we divided by 4. And we get the value of 85. Another definition of an average is this is a number that we can use to replace the other scores, all the scores, by and still come down to the same solution. If you on your test, if Ethan on his test scored a 70, 80, 90, and 100, his average would be an 85. If Paige on her test scored 85, 85, 85, 85, her score would be an 85. You would have the same scores. Why? Because they still all add up to the same number. They still add up to whatever it is, 340. 340 adds up to 340. No matter if it scores 70, 80, 90, 100, adds up to 340. 85, 85, 85, 85 adds up to 340. So when I take these two numbers, add them together, and divide by 2, I get 19. That's the average of the first and my last numbers. So what I'm able to do with that is say, rather than the first number be 3, the last number be 35, the first is 19, the second is 19, the last is 19. Same thing. Because all I'm doing, once again, is adding these up. Well, if I would take the 7 and 31 and add them together, that adds up to 38. I divide that by 2. I could get 19 here and 19 here. Well, I could take 11 and 27, add them together. I get 38, divide by 2. I would get another 19 and another 19. I take 15 and 23, add them together. I get another 38, divide by 2. I get 19 and 19. And now this Lone Ranger that's sitting in there, I can now include. So I have 19 plus 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 19. 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 times 19 because I have a total of 9 terms there. I can multiply by 19 to give me my 171. But do I need to have all these middle numbers in there? Because if I take a look at this, my average of my first and last numbers is the same as the average of the second last number, the same as the average of the third last number, the same as the average of the fourth last number, same as the... So do I really have to do all of them? The answer is no. Because all I really need to worry about is the average of our first and last number. Because the average of the first and last number is going to give me the rest of the averages. So the average of the first and last number is 19. Well, how many terms are going to turn into 19? Well, I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 terms that are going to turn into 19. So if I have 9 terms that turns into 19, my multiplication turns into 9 times 19 or 171. I don't have to do all this proliferative stuff here that I have to worry about. So if I take a look, if I want to find the sum of my first 10 terms, I add another term in here, which would be 39. Now my first term is 3, my last term is 39. I want to find the sum of my first 10 terms. Well, let's take the average of the first term and the last term. I have 3 plus 39 divided by 2. That's the sum of my average of my first and last term. Then I now have a total of 10 terms. So I can multiply that by 10. So I have 42 divided by 2, 21 times 10, or 210. But the key is I need to know what is my first term, and I need to know what is my last term. Well, what if I said I want the sum of the first 101st terms? My first term is still 3. But what I need to find is what is this term 101? Well, what type of sequence do we have here? Ella, what type of sequence? Arithmetic, what's our common difference? 4. We have an arithmetic, a common difference. Whoops. Oh my gosh. A common difference of 4. Arithmetic. Here's my first term is the value of 3. Can I find the 101st term? Yeah, that's what we did the last couple days. I know my first term. I know my common difference is a value of 4. I'm trying to find term number 101. So I can now go back to what we had yesterday. Tn is equal to T1 plus Dn minus 1. I want to find the 101st term. So I want to find term 101. My first term is a value of 3. My common difference is a value of 4. My term number I'm trying to find is 101 minus 1. So we have 100 times 4 plus 3. So our term 101 is 403. So now I want to find the sum of the first 100 first terms. I need to take the average of my first and last term. My average of my first and last term. So I can average them. 3 plus 403 divided by 2 gives me my average. And then I multiply by how many terms do I have here? Because my first and last term is going to turn into this average, but my second and last term will turn into this average. Third and third last term will turn into this average. All my terms will turn into this average number. So how many of these will we have? We will have 101 of them. So we have 406, 203, times 101. Jade, what do you come up with? 20,503. So in general, when we have an arithmetic sequence or series, I want to find the sum of n number of terms. We have term 1 plus term n divided by 2. The average of the first and last term. Whatever term I'm dealing with here. I take the average of the first and last term and multiply by my total number of terms. And once again, my n value is told right here. How many terms do I have? The geometric is not as exciting of a mathematical issue as the arithmetic was. You can do a lot of mathematical wizardry. When we talk about with the arithmetic, with geometric, it's a little bit more cut and dry. We're still, when we're dealing with series, we're just adding them together. To find the sum of a series for a geometric, we take our first term, we multiply by 1 minus r to the nth, and we divide that by 1 minus r. So we take a look at a geometric here. Common ratio is 2. 6 divided by 3, 12 divided by 6, 24. I want to find the sum of my first 14 terms. So we take our term 1, 1 minus r to the 14th power over 1 minus r. Our ratio is a value of 2. Our first term is a value of 3. Bless you. Just have to watch your negatives here. You have to watch your negatives. you deal with your exponents. When your ratio is a negative, I would suggest that you quantify that on top. You can clickety-clack it straight into the calculator, but when your ratio is negative, you're going to want to quantify that ratio on top so you don't lose your negative sign. But you can quantify the top, you can quantify the bottom. You can quantify the 1 minus 2 on the bottom if you want. Janae, what do you come up with?
49,149.
You say 29,000?
49.
49,000?
149.
149? 49, 149? Yes, no, maybe so? With that? A lot of clickety-clacking with that one. Okay, once again, if you have a negative ratio, say your ratio is a negative 2, you're going to want to go 3, 1 minus a quantity negative 2 to the 14th over 1 minus a negative 2. You're going to want to quantify that negative sign up top. Take a look at one last one. Okay, I want to find the sum of the first 300 first terms. Okay, you have to first identify, do you have arithmetic or geometric? Is it arithmetic or geometric? Okay, then at that point, you have to, once it's arithmetic or geometric, if it's arithmetic, you're going to have to find term 301, which means you're going to have to find your difference. If it's geometric, you don't have to find the last term, you just need to find your ratio. So is it arithmetic or geometric? Sarah, what do you have, arithmetic or geometric? Arithmetic, common difference of 6. Okay, so you can find your 301st term. So once you find your 301st term, then take your average of your first and last term, term 1 and term 301, take the average of those, and then multiply by the total number of terms you have. Should get term number 301 to 1805. And then you can take the average of your first and last term, 5 plus 1805, and then multiply it by the total number of terms, which is 301. You should have 905 times 301, I think. Cindy, what do you come up with? 272,000, what?
405.
405. Go with that. All right. My suggestion to you as you go through the problems today, once again, go through the ideas of what do we have here? Okay, is it arithmetic or geometric? If it's arithmetic, I'm going to have to find that term number then, which means I need to know my difference. If it's geometric, all I need is my ratio. I don't need to know the last term for geometric. My geometric, all I need to know is what is my first term and what is our ratio. Don't need to know that last term. It's a little bit easier with geometric. Okay, so identify what type of series you have there, and then do your calculations. I give you some just basic sequences, but then I also give you some recursives. So in problem number 4, 3, and 4, that goes into a recursive idea. So you have to identify arithmetic, geometric. My suggestion to you, once again, when you have a recursive one, my suggestion is write out your first 3 or 4 terms. And then it's a little bit easier to see. If you do the problems here and practice this, you'll get used to these formulas real quick. You won't have to sit there and continue to look back to them. But if you don't do any practice with it, the formulas will become a little bit more difficult for you to remember. So you just need to practice using the formulas. They're not tough to use, you just need to practice them and you'll get used to them. Once again, tomorrow and Friday we'll just have, tomorrow and Thursday, what's today? Wednesday. Tomorrow we'll have a worksheet. That's sort of what we have here again. Friday we'll just have an in-class assignment. Now leads them to next week with a quiz.
Oh, that's true. Senior service day is Friday.
Oh, it is? So you guys ain't here on Friday? I guess we won't have an in-class assignment on Friday then. I'll just have for Justin, that's it. That's right, I forgot senior service day is Friday, isn't it? All right, we won't have anything on Friday. That means Friday and Monday I'll have off, huh?